We can get started. Good afternoon, everyone. So my name is Vincent Fages. I'm in charge of the product management for Denodo. Denodo is a data virtualization platform. So I'm going to talk to you today on how to leverage data virtualization in machine learning and AI landscape. So to get started, what I try to do today is to take you through what is advanced analytics, what we recognize as being advanced analytics, look at what are the data challenges nowadays we are facing, and also to understand what is the rise in complexity in terms of data architecture and how we can tackle the data pipeline issues. And then I will try to take you through a real-time demo. So it might be failing, but that will be real-time anyway, and present you some key takeaway. So if we look at what is advanced analytics, and if we look at the analytics, I mean, you can look at four different phases of analytics. I mean, the descriptive analytic, which tell you what happened, the diagnostic one, which tell you why this has happened, and then moving forward, you try to do then predictive, try to predict what's going to happen, and going further, trying to do the prescriptive analytic, telling you what to do to get the right things. And if we look at the challenges, I mean, there is really a chasm to bridge and to get across. The further you go in terms of the productivity and the value proposition. So moving forward, you need more and more advanced analytic tools in order to get access and to get value out of your data. Moving next to the fifth level of analytic, which is like the autonomous analytics, this capability for the algorithm to take their own decision and to make sure they change the data, they change the behavior to get the right result and what is expected. So if we look at what is the key and what is needed for advanced analytics, is the raw material, is the data. And the problem is that you've got data everywhere, all over the place, in different forms, different formats, in SQL, no SQL, in a cloud, on-premise, multi-cloud. And even the big data platform are starting to embrace the advanced analytics space, but with using Spark ML, this kind of technology. So looking at the data challenges, and without data, you cannot do any analytics. So looking at data challenges and what the data scientists are doing, I mean, most of the time what they do is they spend time to try to basically identify the data, find out where the data are, in which form the data are, whether they can leverage the data, can they use this data, and this is a cycle, and this is coming back and back, and they spend 80% of the time trying to get access to data to find out whether this is the right data, whether they have the right to use the data. Now with GDPR, it's getting more and more complex to make sure they got the authorization to get access to the data. And basically, 80% of this time is trying to find the data, and 10% of the time is to do data science, analytics, and the other 10% is to present the data and to get a result. So the issue is, what can we do to facilitate their work and to help them to spend 80% of their time doing data science versus 80% of their time doing what is 20% of the value of what they're doing. And if we look at the issue, is the data access is really like a Wild West expedition. I mean, you need to find out where are the data, do they have access to the data, in which format, how can get access. So the data scientists become a hacker. You need to transform, to prepare your data. It's so complex to get access to those data to make sure you can do and get the right machine learning, the right algorithm. So the way to solve this Wild West issue could be the data lake approach. I mean, the data lakes, it's a good way to have cheap storage, to have massive processing capabilities. You lower the cost of your storage, you know more in data warehouse. I mean, you can leverage processing capability. But the issue is it has a cost in terms of initial investment. You need to manage, you need to govern. Everyone is talking about data governance, replication of the data. You keep replicating the data in your data lake. So by the time you get the data, and by the time you can start to consume the data could be started to be out of space, out of date. And basically, it's really a challenge to manage data lakes alone for data scientists. So the solution to address these issues, to address these challenges with this huge amount of data, could be the railway. To go to the west, the railway, data virtualization could be the solution for you guys. So basically, data virtualization allows you to shorten time to the data, allow you to maximize different technology, whether they are cloud-based, Hadoop-based, or relational database sources. You can optimize your initial investments. Basically, you make sure that you can delegate some processing to the source. You don't replicate again and again your data. You multiply the number of data, you mutualize the data source infrastructures. You make sure that you get access to APIs. You provide a unified way to consume your data. And you still do that without replicating the data in a secure manner by providing the capability for the data owner to control who's accessing the data in a secure manner like you will do on relational database. Sorry, I went too fast. So, and then, I mean, if you look at what the analysts are recommending, and if you look at what's happened back in the 80s, you move from operational applications. So now we started to move all the data to enterprise data warehouse. The data warehouses area started. And then back in the year 2000, I mean, the amount of data started to explode. The form, the sources started to get out of control. So everyone started to say, fine, let's go for data lakes. The data lakes could be the solution to get this cheap storage, to get this massive processing capabilities. But then what we found out is this started to get out of control again. I mean, you cannot cope with the volume. You're not certain that the data you will put in data lake is valuable. You need to be able to make sure you need this data before to put them in the data lake, and by the time you process the data, it's too late. So the analysts started to say, okay, fine, you need to start to think about logical architecture, logical data lake, logical data warehouses. So leave the data where they are, but present a logical architecture. So on the paper, this is wonderful. I mean, it's logical, you don't replicate the data anymore, but how does it work? So these logical architectures come with this vision of saying, keep the data where they are, continue to invest on your data lake, on your data warehouse, on your operational data stores, and then provide an intermediate layer, a data visualization layer, a federation layer, which will allow you to decorrelate the business consumption of the data from the sources. So make sure that regardless where are the data, regardless the form, the business user can consume the data. You can consume the data either through visualization tool, either through data services for API management, API platform, or through data catalogs. And this is really, if you look at the Agile infrastructure requirements, I mean, most of our customers live in this space. I mean, you get data all over the place. You've inherited the data from different systems, from legacy systems. They are in the cloud, on premise, and for good reasons. But what a business wants is they want to process the data, to message those data. So basically, they need to make sure they do some data quality. So they're using data quality tools. They connect to the data sources, and then they produce clean data sets. So they started to build some pipelines to get pipelines to plug the sources with the analytics tools. Then you start to do some data science. Again, you need to consume raw data plus your clean data sets. And then once you get your data, then you need to feed machine learning engine. Again, you continue to bring some pipelines. You plug things together. And the further you go, and the more it's difficult to unplug the things and to move the things. And then once you get results, you want to share it with dashboarding application, with visualization tools. And basically what you feel like is there is a gap between the business users you're doing with your data versus the storage of your data. And so what you need is a data access layer, a layer which will allow you transparently to get access to your data, to govern your data access, to make sure you manage the security, to make sure you know who's accessing the data, you can audit, you can trace the queries. For GDPR compliance, you need to know where are the data, but you also need to know who's accessing the data. So you need this data virtualization layer. You need this capability to federate, to get access to the data in a right way, in the timing manner, in real time, provide this capability to manage the security, a role-based, a user-based security, but also to provide a new way to consume the data through data catalogs and through data governance platforms. So really, this is where are the benefits of a virtual data layer. I mean, improve the decision making by shortening the time, the development time to get access to the data. So make sure as quickly as possible, you can get access to your data, you broaden the usage of your data, and you don't go against the performance. So you still bring the data in a timely manner and in a performance way. So that's the vision of data virtualization, and this is what Denodo is bringing. So rather than keep talking, what I'm going to do is I'm going to try to give you a quick demonstration, so to show you how using a data virtualization platform you can do some machine learning, and you can leverage Python environments, you can leverage multi-source federations using the Denodo platform. So what I'm going to try to do is we're going to try to predict the usage of the Citibikes in New York. So in order to predict the usage of Citibike in New York, we need to get access to the Citibike data. So we're going to get access to the Citibike usage. And then what we need to do is we need to cross this data with some other data. So one way to impact the usage of the bikes is likely to be the weather. So you can imagine that if it's snowing, it's less likely that you get some bikes used, but also it could depend on the day of the week, whether it's a bank holiday or not. And so basically we're going to consume data from the National Weather Station. We're going to federate those data, we're going to prepare those data using the Denodo data virtualization platform, and then we're going to use a Python random regression tree algorithm to provide and to present the results through the data virtualization platform. So as I said, we're going to connect to the data, we're going to have a look at the format of the data, see how we can, within the platform, continue to ingest Python algorithm and to produce the data and to predict the data and to compare the prediction versus the real users of the data. Okay, so let's try to move into a demo. So I need to put my glasses on, and normally, I hope this is not where everything is failing. So you can still see. So the first thing I'm going to do is I'm going to log through. It's gone. Okay, fine. So this is when this is failing. So and should come back, hopefully. Good. Okay, let's assume this is not going away anymore. Okay, so what I'm going to do, first of all, I'm going to connect to the Denodo virtual modelization platform. So our product is like an SQL developer. So you're going to create a virtual data model using Denodo. So the first thing I'm doing is I'm connecting on my platform, and into the VDP admin tool, which is a virtual data port admin tool. What I do, I manage virtual database, okay? So on the left-hand side, you can see I've got virtual database. And on the virtual database, the first thing I'm doing is, before to create virtual table, I need to create data sources. So I've got this capability to manage connectors. Okay, sorry. This to manage connectors, so I can connect to any kind of data sources, JDBC, ODBC, multi-dimension database, Salesforce, SAP, using BAPI, LDAP connectors, or I can even create custom connectors. So, I mean, we connect to anything, and if we don't have the connector, we have an SDK which allows you to create your own custom wrapper. So the first thing which I did is I create connectors to my weather historical data. So I've got those data to an Excel format, but it could have come from an API or from a data services. And then once I've created connectors, then I create what we call base views or basic views. And on those base views, basically I SQL enable those views. So once I've got those base views, I can start to run SQL queries, like do a select start from my weather history, and then I provide SQL capabilities onto my sources. So I can run this SQL query and have a look at my results. So I can see that my weather information are coming with some data. Some of the data are numeric data. You can see that some of the numeric data also have characters. So in a rain or for the snow, I've got some T. So T is not a value which I can use in machine learning. The T means trace. So what I need to do is I need to process those data, to transform those data before to send them to the machine learning algorithm to put a value. So I'm going to replace this value with a very low number. So let's put 00.1. That would be a low number, and I need to cast this data. The other thing is, if I look at the dates, I mean, if I look at the 1st of January or the 31st of December, those two dates are very close. But in my data sources, it's day number 1 and day number 365. So what I need to do is I need to apply a cosinus function, so to have a cyclic views on those data. So I'm not going to show you how to do that, but what I'll do is I prepare a set of clean data, which I'm going to call like my ride encoded. And then if I have a look at those data, and if I look at the way those data are prepared, so I've created a join between like my weather information, my bike usage, my date dimension, so I need to know whether it's a bank holiday, whether it's a Sunday or not. And then, using the virtual database, I've created outputs, and I've been able to apply my transformations on, so like the cosinus transformation I was mentioning before, and therefore, all those data now are usable by a machine learning engine. So what I can do is I can move to my Denodo data catalogs, for example. Then I can connect, normally I should be able to connect to my data catalogs. So my data catalog is a business user view, or it's a view for the data scientists, which will allow the data scientists to introspect which are the data available for them. And then they can look, okay, fine, I want to have a look at any view or table that has weather information. And then by doing a search, automatically I can see I've got like my table available, I've got my table transform, and depending on the right and the permission I've got, I can directly also get my connectivities to my different sources. And what I'm going to do is I'm going to use a notebook to do my preparation and to work with my data. So within the Denodo, we have integrated the Zeppelin notebook, so the data scientists can directly start to have a look at the views which are available for them. So I can run queries on the data, do some aggregation per month, per day. They have a look at the data, so I can see that when I've got a very low usage of the data, it's during the winter, so which is fairly enough normal. And then, so I don't have to worry anymore. Where are my data? Where are they coming from? The data virtualization layer allows me to get access to the data I'm entitled to get access to. Then the only thing I can do is just do my data messaging processing, and then I can move further and start to have a look at my transform and my clean data sets. And running the query, you can see that now in the data set where I used to have T, I've got data with like a very low numeric value. I can have also data information regarding the dates, so I've got the cosinus information, and this is happening in real time. So when I trigger a query here, using the JDBC connector, this is happening in real time, it's going through the source, and the data virtualization engine is orchestrating all those queries. So, and then the other thing is then I can start to write my Python code, and then I can connect to my data source using ODBC connection, so I can start to feed my different data sets, so to get the data which I'm going to use to train my algorithm, to get my sample data which I'm going to compare my algorithm result with, and transparently I've got my data, be able to run my random forest regression tree feed, so I'm feeding my tree, and then I can start to compare and get my result out. And then as soon as I got the result out, I can compare my predictions with my output. But also what I did is I also persist my data through a virtualization layer. So the data are also available now on an S3 sources, and I can move and have a look at other visualization tools like Tableau. We have native connectors in Tableau, for example, in Power BI, in MicroStrategy, and so you can present the data and the result directly without having to pass over the data. And so you can, in real time, present the data which are coming from your algorithm directly from the data sources. So if we move back to our presentation and where I was, basically, and this is when we're going to lose the presentation. So as a takeaway, so basically, if you look at what is Denodo and data virtualization, so if we look at what is Denodo and data virtualization, Denodo is a platform which allows you to connect to any source, as I mentioned before. So we'll be able to connect to relational database, to whether it's in a cloud, on premise, to big data, HDFS clusters. We connect to SaaS applications, Salesforce, Workdays, APIs. So we have a native API connector. We can do paginations, but we also connect to non-SQL data sources. We can connect to structured file, XML, JSON, CSV file, and we bring this processing capability to those sources. So what we do is, in the middle layer, once we got the connectivity, we provide you the capability to create a virtual data model, this capability to have a powerful SQL engine on top of any source, and we bring all the functionalities that a modern database is capable to bring in terms of role, user management, audit, traceability capability, but also caching capability, massive parallel processing capability. So we provide, we are a SQL optimization engine, so we don't do federation. We really delegate as much as we can to the source, and we become a very clever consumer of your data sources. And if the data sources do not have any processing capability, then we bring the processing capability. And then we present the data through 3 different manners. The first one is through query capabilities, through JDBC or DBC, for application through BI tools, as I mentioned before. The second one is through data services, using web services, SOAP, REST, JSON in open API, in open data format with an open API. We also implement GraphQL, so you can directly using GraphQL to introspect the data through the data virtualization platform. And the third vector of exposing the data is through the data catalog. This business users, this user interface which you've seen, which allow you to give a unified access to the data sources to the business users. So really the vision of Denodo is to make sure we provide access to any data regardless of the location of this data, regardless of the format, but in a unified way so you can better consume in real time as much as you can your data. So as a takeaway, we are available on the Azure and AWS marketplace, so you can go. There is a test drive, so you can start a Denodo instance. You have a use cases for data scientists, machine learning, so exactly the same as the one which I'll demonstrate to you. So you can have a look, test it by yourself, and you will see what will be the benefits of data virtualization and Denodo. Thank you very much.